No, because the table is here. There's PowerPoint there. So just.
We're going to continue our two-day workshop about the doctor from Mr. Burhan Khalid.
Okay, thank you. Last week we discussed a bit about Docker, and I gave a small presentation. Unfortunately, my laptop's battery ran out, so I wasn't able to complete my demo. So this week there's no presentation; it's just a straight workshop. If you can follow along on your laptops with Docker. So, as we discussed last week, Docker is an application container. It takes the common parts of your application without the operating system. It packages them in a portable format so they can be deployed on multiple workstations. And because it uses capability of Linux, it is currently only available strictly on Linux machines. So if you have a Mac and you download, or Windows, and you download the Docker, you'll actually download a Linux image which runs in VirtualBox, and you will be running Docker inside it. Okay. So the first thing that you want to do with this exercise is make sure Docker is installed. Now, if you type the command Docker info and hit enter, it'll tell you statistics about your Docker installation. Now, if you are running on the Mac and you get an error message, you need to run sudo docker info, like that. Okay? This is because by default, the Docker daemon communicates on a socket, and that socket is owned by the root process. If you create a group called Docker and add yourself to the group, the next time the Docker daemon starts, it will change the ownership of the socket to the Docker group, and then, like I did here, you'll be able to run Docker commands without using sudo. Yes?
So restart Docker is basically service Docker.
Yes. Docker just runs like any other service in your system, so you can just restart it using whatever the flavor of the month system D or initd or whatever you're using. Okay? But this is what it gives you information about. It tells me I have 7 containers, I have 86 images, this is my storage driver, the amount of CPUs, some information about my system, the ID, and various information. Now, there are 2 concepts to Docker that you should be familiar with: a container and an image. Okay? An image is just a template. It is a read-only copy of a directory which you run, then modify. So when you run it, it's called a container. When it's frozen, it's called an image. Okay? Is that clear? So containers are running processes. You can see any process that's running on your computer by typing docker ps, which is similar to the normal ps command. This command shows any currently running containers. Okay? As you can see, if you run it on your computer now, you'll see a line similar to this, which shows you that there are no running containers. Right? Is that correct? You type docker ps, should just get the columns, which means there's no running containers. In order to run a container, you need to have an image. An image is, like I said, a snapshot which you can run in Docker. If you type Docker images, like that, and you hit enter, if you have images like I do, you'll see statistics about images that are available on your machine. Okay? So I have a couple of images downloaded off the internet. I have an Nginx image, I have an Ubuntu image, I have Python image, I have a Postgres image, I have a Redis image, I have a RabbitMQ image. An image is just a stripped down virtual machine in a frozen state. You cannot run it. If you have no images on your computer, okay, the first thing that I want everyone to do, those people who are not paying attention, thanks. The first thing I want everyone to do is just type docker pull, okay, space, Python, and hit enter. Okay. For those of you that don't have any images, it will start pulling the Python image, and you will see something like this. So what I'm going to do now, I'm just going to delete the image from my computer. It should not allow me to delete it. Actually, it did. So docker pull Python, and there it goes.
A question about the Python image. I think it states that it's not safe to use it in production. Do we have to, for production users, do we have to get the one-to-one image and then stage it to the Python image, or what exactly do we have?
Where does it state it's not?
I think on the house.
It's just an example. It's just an example. Okay. Now you notice on my machine, it says already exists, already exists. Okay. Docker images work on a version control file system. So if that part already exists, it doesn't fetch it from the internet for you to save you bandwidth. So all it's doing is just fetching the part that's missing from my Docker images. Okay. Once it's done, it'll extract it. It'll be, and it gives you this. The image you are pulling has been verified. This is a test system from Docker. When you just say Docker pull and you give it an image name, it pulls it from the Docker official repository of images. But this is a public site. Anyone can go and upload images, right? So they're working on a way to verify images. Okay. Now, if you type Docker images, you'll see Python is available, and that was the created is when it was created by the owner. Okay. Is that clear? So now let's run the image. Just type docker run Python, just like that, and you hit enter. Watch what happens. Nothing. Well, something did happen. Right? You got your prompt back, and if you type docker ps, nothing is there. What actually happened? Docker by default, when you run a container, when you run an image, it runs it. If there's any process, it will block it. Otherwise, it will immediately exit. So the Docker image, the Python image I'm running, it doesn't have a process that runs once the image is brought up. So actually, if you do on your computer docker ps -a, it shows you all the containers that were running at some point in time. And you'll notice this one, the command that it ran was Python 3, and then it just exited because there's no hook for you to interact with, right? So what we're going to do now, we're going to run the same command again, docker run, but we're going to say, what this does is, T is for the TUTI, or the TTY, the terminal. I makes it interactive, and then this is whatever command you want to run when the container boots. So I'm running the shell. What will happen is it'll immediately boot the thing. It'll give me a shell inside the container. Now, to prove that this is running, you open another terminal window and you say docker ps, you'll notice here it is. Right? So this is the container that's running in the background. Okay? You can tell that's the container because it has the same container ID. Like the container ID here is the same one, oops, that you see here. Right? This is the image that's running. This is the command that's running. It's up for 11 seconds. There are no ports being mapped. And Docker assigns it a random name. So it's always two words with an underscore. So if you want to refer to this container once after it's running, you can use this name to refer to it, or you can use the container ID to refer to it. But now that the container is running, it is just like any other virtual machine, except for one very big key difference. This machine is running directly on my hardware. There's no hardware virtualization. Okay? It doesn't ship with an operating system. The operating system and kernel layers are controlled by the Docker team. So I can do everything I can here. This is a complete Linux system. I can, but this command is not a Ubuntu system. I can run Python on it. And everything's running fine. The reason it's running 3.4 is because the command I gave was docker run -it Python. So it always pulls the latest image. You notice that it says latest here. This is the tag. So this is the version of the image it's running.
Who's doing the images?
Anyone. There are some images that are officially from Docker. There's some images that are from, like, for example, the Ubuntu image is from Ubuntu. They're supporting it. The Nginx image is from Docker. So you can go to the Docker public registry and you can see who created what image, which are the most popular images available. There are private registries also. For example, Red Hat has a private registry for their images, which is only accessible if you have a Red Hat subscription. It's not accessible public. You can create your own image repository and store your own images and let Docker pull from those images. Okay? So one of the key things about Docker is you can make changes to an image and store it and go and revert back to it. So what we're going to do now on this Python image that we launched, we're just going to install Flask. So what we'll do is we'll just say pip install Flask. Okay? And just like any other normal system, it's going to go ahead and download Flask, install it. It gave me a warning that pip was outdated, so might as well upgrade pip. So pip install upgrade pip. So I'm going to download the latest version of pip. So I made some changes, right? Let me exit out. And now I'm back at my computer. If I go here now, you'll notice that the image is gone from the list because Docker PS only shows running images. But the image is not deleted from my computer. It's there. If I do Docker PS -a, you will see it's here. It's the last image I ran, which was right here, Lonely Curie. It's the first one listed because it just exited 15 seconds ago. Okay. Now what I'm going to do, I'm going to take this image and I'm going to save it. I'm going to take this container and I'm going to save it as a separate image. Okay? That way, the next time I boot it up, I don't have to do these commands again. It stores the state. So what I'm going to do is I'm just going to type, oh, wait a minute. Okay, here I am. Let me clear my screen. Docker, commit, give it an author, give it a message, okay, and give it the container ID, which is from here, this number. So I'm going to say 0361 B9 AD 6856, and I'm going to give it a name. So I'm going to give it a name. I'm going to say, what it's going to do is going to save that version of my container as a separate image. How do I know that? If I go Docker images, You'll see it's right here now. I just created it 9 seconds ago. Okay? Yeah.
The same size of this image or just the frozen?
Just the incrementals. But an image is a frozen copy. So now if I run this Python Flask, it should have Flask installed in it. Right? So Flask is there. Right? Now, what I just showed you is typically how a Docker tutorial works. You take an image that's pre-built, you run it, you make some modifications, you let it run, you save it as an image. You don't necessarily have to save it as an image. If the image that you downloaded does everything you want to do, just run it as a container, stop the container, start it up again. So a container has some state, but a container is the running instance. An image is, you cannot go right to an image. You can only create another image. Okay? This is one way to create images. The other way to create images is to use a Docker file. A Docker file is just a plain text file on which you write commands that will execute, and if the commands are successful, automatically an image is built. So what we did right now, we can easily use a Docker file to create that. So anywhere on your directory, just create a Docker file. That's what we call Docker file. You say from Python latest. Okay, this is the image that we used, right? Run pip install Flask, and then run pip what was it? Upgrade pip install upgrade pip, right? And that's it. That's all we did. These are the only two commands I ran. I can save this file and then watch what happens. Oh, it's always a good idea to put who contains this. So maintainer, and then just say name. So if you write these 4 lines in a file, make sure it's called Docker file. Save it. Okay. And then do Docker build. Okay. The name you give is the name of the image it will create if the build is successful. The dot means the Docker file is located in the same directory. So let's just hit enter here. Oops. I think I missed the order of the arguments. And then T, I think. Here we go. So what it's doing now, it's downloading the image. It's going to run the commands that I just ran. Oh, oops. It's building my entire home directory into the Docker file. I forgot to mention one key thing. The folder in which Docker build is created, it's going to take all those files, it's going to dump them into the image. That's why the image size went to 1 gig. So, I already have a V2 and then Docker build. And I believe, let me look at my cheat sheet because I forgot the, yeah. This is the command, Python Flask auto, and then there it is. So now it's running the command, it's pulling from Python latest. It's each line that I write in the Docker file is a version changed to the Docker system. So it's running pip upgrade, it's downloading Flask, which it already did, and it successfully built it, and it's successfully built and saved in my local Docker images. So now if I do Docker images, you'll see I have Python Flask auto here as well. Okay, good stuff. Any questions so far? Yes.
So basically, what I want to do is expose port 8080 from Flask and serve the hello world.
Other.
How can I push it to another registry or something? So can I use it from another machine?
Yeah, there are two ways to do that. You can push it to a repository, or you can convert it to a compressed tar archive, take that archive to another machine, uncompress it, and run it. There are two ways to do it. To push it to a repository, the first thing you do is you tag the image with the name of the repository. So for example, I have these images, okay? I want to push my Python Flask image to a repository, okay? The first thing I will do is I have to have a repository. Right? I have an account on the official Docker repository. So I have to tag my image with the name of that repository. So Docker tag okay, now if I do, you'll see there's the same image, because the image ID is the same, right? But this has a different name because I tagged it. Now I can just do Docker push, and it should give me an error because I haven't authorized it, but it'll push it to the Docker public registry. Similarly, you can run a local registry, tag it with the full URL of the registry / and the name of the image you want, and optional the tag that you want. So I can say, these are my images. It says, it says latest. This is the default tag it gives. So I can give it my own tag. I can say Docker tag Python Flask auto to Python Flask auto version 1. Okay, now there's a version 1. Same image, different tag. Tagging obviously is important because the idea is images should not be changed much. Images should be uniform. Whenever you make a revision, you create a new image and you tag it as if it's a version of the image going up. Okay? For example, where I work, whenever we make a new push, we tag the image with the date that the push was made. So we always have a list. We can always go back to the last date or the previous date where we had a push and just load that image again.
But any changes to any image of that tag would be in all other tags, right?
No. If I load this image, the version 1 image, right? If I run it, how was it? Okay, I ran it. Now let me just make a small change. Let me just create a file. Okay, small change. Exit. It's not an image yet. It's a container because I ran it and I exited, right? So I have to look at my container list to find out that it's here. This is the name of it, right? The one I last created. Now I'm going to convert it back into an image. So what was it? Last 3?
The first 3.
First 3, right? So Docker commit change. Can you see the bottom? Yeah. Change in image. This. Oh, oops. Yes, E06. and then we'll call it another name. Call it version 2.
So you are creating a new image.
I'm creating a brand new image with the change. Okay. If I don't do this line and I run the container will have that change, but the image will be different. Does that make sense? You can only make changes when the image is running, right? Because images are read-only.
It's the container.
Well, yeah. So when the image is running, it's called a container. The container is actually the process, right? The process is the container. I have all these containers, which means these are images that are available for editing, right? I use the version 1 image to load a container whose name is this insane Engelbart, right? And I made some changes in it. If I run this image again, the changes will be there. But they will not be in the image, in the original image, because it's not affected. If I save this container with the same name as the original image and a different tag, it will be a unique image by itself. Next time I run it, it will have my file. And the original one will not have my file.
Now, after running the image and doing some changes, if we terminate that container, just offline,
Yeah.
and run it again,
Yeah.
we'll have the changes?
Well, let's see it. It stopped right now, right? It's not running. It's exited 8 seconds ago. So right now, there's no image running, right? I'll run that same image again. So to run the image, run -I, start, right? Abdurrahman, was it? Start?
No,
Run? Yeah. Run the container. Start. Start is for containers. A means attach. I means interactive. And you have to give it the name of the container. So remember the name of the container? Insane container, not the image, the container. So this is the name of the container. Start AI paste and dash. Oops. Here is the container, right? File is there.
What is the difference between .start and .run?
Run when you have an image and you want to launch a container. Start when you have a container that's stopped and you want to start. Start for containers, run for images. So when you have an image, which is not, you don't have a container for it, you run the image. Once you run it, it's a container, right? A container can be stopped. So if a container is stopped and you want to start it, you don't say run, you just say start. And you give it the name of the container. Okay? You cannot have two containers with the same name, which is why it generates random names for you all the time. Okay? So does this answer your question?
Yes. One more.
Sure.
Now we have the image. We run it.
Yes.
This is a container.
Yes.
We did some changes.
Yes.
We terminate that container.
Great.
We cannot run it. We only start it because it is a container that we stop.
Yes. Yes.
We cannot rerun the image, can we?
We can always create another, we can always launch another container from the same image.
And it will not have the changes.
It will not have the changes. So this, I will leave this container running. Okay, I will not close this window. Okay, so the container is running, right? Version 1. What happened? What? Yeah, so? Oh, sorry. Slight pause while we, commercial break, as we go ahead and share the entire screen. Is that better? Okay. That's worse. I have so many windows open. Which screen do you want me to share?
One that says screen. This will treat this as a screen. No.
Then?
Entire screen. Can you go down? There's more.
Yeah.
This is weird.
Which one? Okay, let's just continue so we don't stop.
Yeah.
So we don't stop the thing. So here you can see the container is running, right? We use the Python Flask Auto image, version 1 of that image. Now I'm going to launch another container with the same image and the same tag. So it's Docker run, not Docker start. So Docker run it auto v1 hash. Okay. So you notice this number is different? It's a unique instance of the same image. Okay. Now in this container, it's not good. So an image is like, for example, a database server is an image. You take that database server without any data inside it. It's just the server. You run it, and then you attach it to a directory where you have the database files, or let's say a web server. It's an image. You launch the web server, and each instance you map another directory to it, and you have multiple copies of different websites running, but using the same image. Does that make sense? We didn't touch on mapping data or how data is stored, because if I delete the container, the data is gone. If I delete the container, foo text is gone because I didn't save it.
Unless this data is from the original image.
Unless this data is from the original image, yes. Because remember, it's a versioning file system. So it stores only the deltas. Okay? And it builds images on top of each other. So in that Docker file, each line, it's actually an image being built. And then they combine it together to give you the final image. Questions?
So how do you map it?
Okay, so the question is, this is great, but suppose I want to run a server. How do I get the port? How do I get the networking going? Okay, networking is very simple in Docker land, I would say. Okay, let's take a simple instance. Let's take this image and create a simple Flask application. Since it has Flask already installed, so I'm just gonna Vim is not installed. That's nice. So let me do something even simpler. So in this directory, I have my Docker file, right? This Docker file, if you remember, it just uses the latest version of Python, and it installs Flasks and it upgrades it, right? I'm going to change the from line to use my image that I have. So I'll say from, what was it? Python Flask Auto version 1, right? I don't need to run these commands because they're already there. Let me get rid of this. Let me get rid of that. What I want, yes, I apologize for those elite people who want me to use DD to delete the lines and X to delete this. I am happy to oblige. But for old guys like me, Allah you speak. A notepad, Emacs. All right. So what I want to do now is I want to take a directory from my local machine and point it to the container. Okay? So containers have a concept called volumes. A volume is a directory in the container that is mapped directly to a directory in your operating system. Okay? So what I'm going to do, I'm going to make a directory called site in the container. And I'm going to just say port. Yeah. So this port from the container is going to be exposed. It's going to be made available for me to do whatever I like with it. If I leave this line like this, the port is only available to other containers. It's not available to the host. I have to map it to the host. Okay? So all this is doing, taking that Flask, making a directory called site in it, and exposing a port. I'm not running any commands. Right? My Docker file is very simple. Let me build this image. How do you what? Yeah, you'll see it here in a few seconds. Docker build, and let's say Python Flask v3. Build the image because there's only 3 lines to it. There's nothing to do, right? In the image, there is a directory called site. And if I go here and
you build the image with any configuration, right?
yeah. So it's there in my list of images. It's version 3. It's the latest one. Now, what I'm going to do is on my host, I'm going to write the code that I need to run. Okay? So okay. What? Yeah. Happy? I was going to demonstrate something, but he caught my typo. And so this command is here. It's on my local machine, right? What I want to do now is I want to run the container, map this to that directory, and in the container, run this file. Okay, so Docker run. This is the port. So it was 8,000 there, 8,000 here. So 8,000 from the container to 8,000 on my local machine. Routing. Routing, mapping, porting, masking, masquerading. Shut. V means volumes. Okay? A volume is a folder in the container that is directly linked to a file on your machine. There are 2 ways to add stuff to a container. You can use volumes or you can add. There's a command called add. Add literally takes it, copies it into the container, so it's part of the image. It's frozen in time. It cannot be changed. Volumes are live, which means volume is a live mapping. The trick is when you're doing development, volumes come in very handy because you can have a container that has your entire application running, right? And all you want to do is you want to test a new version or something. So you run the container, and you use the volume command to map an existing path to your local machine. Whatever is there will be deleted, and it will be pointed to that, just like as if you did mount in Linux. When you do mount in Linux and the directory has files, it gets rid of it. It works exactly the same way. So it's very good if you have an application running source code. It's part of the container. It's part of the image, which means it's the production code. Because whenever the image runs, this is the code. You want to test a new version. So you run the copy of that image, and you map that path to your local drive, and all of a sudden now it's running in the image. I'll show you that trick as well. But anyways, here's what you do. You give it, actually I can just, and you can map directories, and you can also map individual files. So in this case, I'm going to map a file. I'm going to say main.py, put it in, what was it? Site, main.py in my image, and then run Python site main.py. And put it in the background for me. Because if I do IT, it'll run it, it'll block. I want it to run as a server.
Minus B for volume. Then this command with the path.
Okay, let me explain. Docker and Docker. Okay. B means daemon, like run in the background. P, it's for port, and you can repeat it if you have multiple ports. P is for volumes, and again, you can repeat it, multiple volumes. Okay. This is the command you wanted to run. I forgot one thing. What did I forget? The name of the image. It's like, what's the image you want me to run? So the image is called Python Flask and version 3 of it. Finally, the command I wanted to run. Okay, so hopefully, that's not what I expected. Maybe because of this. Why is it doing that? It's picking up this as a separate, it's giving me the Docker version. So I think what I have to do is run. I cannot believe I forgot that part. And no one mentioned it. No one mentioned, Habibi, you forgot run. I did actually. So now you can see that the Docker image is running successfully. How do I know that? How do I know if the image is running or not? Wow. Curl, telnet? I said, how do I check if the image is running? How do I open it up and Docker PS? Docker PS. It's running, okay? Where is it? But for some reason, the ports aren't mapped. It's not showing me the right mapping.
You said here this is version 3, the one that's running version 1.
Good.
And this is uptime 15 minutes?
Yeah. So it should not be right. If I do A, it'll say, If I look at all my containers, this one, for some reason, exited immediately after running. And it gave an NZEC. NZEC is non-zero exit code. So if you ever get this error in your program NZEC, it means the error code was not zero. Zero error code means success. Anything above zero is an error. So whatever command I ran, this command that I ran, for whatever reason, it exited. It didn't launch. right? So I want to know why. There is a logs command that you can use to check here is the error, which no one knows. Why is this an error? Python quiz. Python 3. Allah is the only guy paying attention. He gets the Docker sticker. Yeah, but why is it a missing parentheses? Why is it a syntax error? Because normally it's on the syntax error. Where do I fix this file? In my local, right? What else is wrong here? Anything else wrong here?
This is paying attention to.
This he's paying attention to. And ruining my reputation online. Okay. Okay. Shall we check how it's running? Netcat, what was it? Curl minus shino? Curl my hair, yeah, shabab. Docker, PS. Alhamdulillah. Here you go. Here is the port now. Okay. Now, to find out if it's actually running, what was it? Curl? Yeah. Too fancy, I guess. Shinu? What was it? 127? One more what? And then? Okay, so why is it not working? Anyone tell me? Let me go to the browser. Where's my browser?
Oh, I know why. Go to your file, your main.py, expose it to 000 and your run.
Yeah, because I exposed which port?
You expose port 8000 on the local, so it's looking at the Docker. So it's expecting a local connection from the Docker file. You need to expose it to 8000. 000
So you're saying essentially I have to run my container again.
No, not here. Just in your main.py.
Yeah.
You need to change something.
Via main.py, what do I have to change?
In one, I think you need to make the host to be 0000.
Okay. So what is it? Remember?
It's
Like that? Sure.
yeah, and then you need to give it the port. The port that's going to run.
By default, it's 8000.
You're the last time.
Actually, I'm not. But
That's 5,000 or 8,000.
is it 5,000 or 8,000?
I think it's 5. You need to change it in the run to say P equal or port equal 8,000. Yes, I believe it's 5,000.
5,000? Okay.
Now, if you run the same image, 5,000, fine.
Or I can just go ahead and what happened to my screens? You notice something? We're changing in my local directory. We're not running the image again because it's a live connection. So whatever change we make here, it picks it up immediately. So what's the port? 8,000? Yeah? is it? Okay. Let's change it to 8,000. Nope. What else could it be?
The server default is 5,000.
Okay.
And host is 0000.
Okay. So what I have to do now to change the default?
It's either you can map it on the you can either map it to the image, so you're exposing 8,000, but you map 5,000 to 8,000.
Okay.
Now that's on the image.
The image is running. I don't need to. I don't need to run the image. The image is running. See?
After the changes, don't you need to rerun it?
No, it's live connection.
They try to.
Let's look at the Docker file. What was in the Docker file? We're exposing port 8,000, right? Now, what you want to do is you want to make sure port 8,000 is being listened to by Flask, right? So what we want to do now is if we look at, and let's load the my images. It's called, sad something. There you go. It's running here. And on 127.0.0.0.1, right? And if I look at my main.py, debug is true, and port is 8,000, but it's running at local, right?
So you need to set the host.
Host to,
0.0.0.
yeah. Now, if I see the logs, it's not going to stop because I have to, even though the file is being changed, because the process is already running, and it's already bound to a port, I have to run here. So what I'll do is I'll just stop my container. Docker stop sad, wallahi sad. And Docker start it up again, right? Now, see, now it's running on this one, right? And here's how it works.
And in the RCC, you have all the.
Now, this was not the smart thing. The smart thing is, now what I can do is from my machine, I can make changes to this guy and say something like fruit shawarma and def shawarma and say I want extra. Okay, I'll write the file. I'm not even close it. And I have never opened so many terminals in my life. Good. Here's another one. And I will say shawarma, and it will say not found. Why is that?
Because the same reason you need to run it. Rerun it.
No, because file locked.
There is a way where you can set it to auto reload.
It's auto reloading. If I close the file, and if you look at the log, see, it's restarting with stat. So if it stats the file and finds a change, it will check this. The reason it's not statting the file is because due to the way stat works, there's, it didn't detect a change. Look at the log. Right? If you look at the log again, it's flagged to restart, but immediate file changes are not shown. This is a quirk with Flask. If you have an Apache web server running, listening on that host, okay, and you make some changes, it's immediately refreshed. But this is kind of simple stuff, basic stuff. What if you want to run a complete big giant application, which has a database, a cache, multiple applications, and you want to scale it automatically and all those other good things, right? So last time in my talk, I spoke briefly about Fig. Fig is an application that was designed to help bring up supporting containers to run your main app container. So we have an app container here that's running our Flask app. If we need Redis, which is a cache, we can import the code here and we can add Redis, add the libraries to our image. Redis is installed. But where is it going to connect to Redis? And where will the port be? And how will all this be taken care of? In Docker world, Docker containers are smart that they know about each other. If a container exposes a port, other containers can know about it. Because environment variables are set extremely smartly. So what I'm trying to say is, if you run a Postgres or a MySQL container, in your application, you don't need to know the IP of the port. You just read from the shell, from the environment, the variables. And Docker will automatically point to the correct IP. Okay. To demonstrate that, I have a sample application which uses Postgres, Celery, which is a task queue, and I believe Redis as well, to run an API. Separate. Otherwise, how you will scale it? Doesn't make sense. So let me show you how that works, because the last time I did this, my computer ran out of battery. Okay, not because it's very heavy, but because it's Linux and it's NVIDIA. It sucks battery. Okay. 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 So here is my app. It's a complete application. Okay. It has a Docker file. It has a Docker compose file. Last time I talked about Fig, and Mohammed Almir reminded me that Fig is no longer recommended for production. For recommended for production is Docker Compose. Docker Compose is actually Fig. They took the same thing, renamed it, and integrated it into Fig. It's so compatible that when you type Docker Compose and you have a fig.yaml file, it will read it. It's that compatible. So Docker Compose, what does it do? Let me first explain the Docker file that I have. Okay, this is my Docker file. Very simple, right? From Python 2.7, not 3. Add my requirements text file. Well, I'm saying add, which means copy the file and place it inside the image when you build it. So it's permanently in the image. Right? Change the working directory to app, install my requirements, and add a user. Yeah, so very simple. My app, I developed it locally. Okay. What does my app need? It needs all these services, and these services I have defined in this file. So my app needs a DB for Postgres, version 9.4, and I'm telling it, give it this password. I can give it, by default, it gives a password called Postgres. Okay. I need Redis, this version. I need RabbitMQ, and this is my password for RabbitMQ. And these are the ports it's going to expose. For the web, I need, you see this build and the dot, it means the web container, there's a Docker file in the same directory use it to build that container, run this command. Once the container is built, mount dot, which is the current directory, to the app volume, expose these ports, link it to the DB, and link it to the RabbitMQ. So this is the linking. This is how the containers know how to talk to each other. Link the image called Redis with this name. Here are my workers. Create an image called worker. Build it from the Docker file. Run the celery command, this batch file in it. Mount the volumes and link it to Rabbit, Redis, and database. Okay, this is what, like 30 lines of code, right? Now, when I run this, watch what happens. Okay. Docker compose and up. Oops. Sorry. Up. And then minus D, I think it is. There we go. So now it's going to, I already port allocated there. So I have to shut down my other container. Docker stop the sad guy. Okay. Try it again. You see, it says found multiple config files with supported names, even fig, so it's using the Docker compose. So if I remove the Docker compose, it will use the fig. It's the same thing. There we go. So now the whole thing is running. Okay. Just give it a few more seconds. It's doing.
You specify also to export to host.
Yeah. Okay.
Is this a Django project?
Yeah.
Could you please show us the settings for it?
Sure. Okay. So I believe it's run. It's running. I don't have to believe in it. I can simply Docker that is running because my PC slowed down. Yep, everything is up. So here are the commands. Here are the ports. This is the port mapping. And here is my 8000 port, right? Now, if I go and if I actually open up my browser and bring it here, refresh this. Here is my API. It's DRF. And I can go to jobs and I can start a job. And I can post to it. Basically, everything is working, right? Here's the beauty of Fig, or my mistake, Django Compose. I want to now scale up my workers. Okay. So what I can do now is just say Docker Compose scale worker 5. It's done. I don't have to worry about ports and configuration because it takes care of that for you. Now when I see you'll see other workers are up and running. Watch something. What do you think will happen if I try to scale my web?
You wouldn't be able to, because there are some the same problem.
Right. No, that's not it. If I let Docker manage the ports, I can even scale my web, because it'll assign each one a random port. And then I have to have a LB sitting on top. Right? If I try to scale the web, it'll tell me, hey, you're trying to scale the web, but you force bound a port. If you let me manage the ports, I can scale the web. Here. See? Remove the colon from the port definition in Docker Compose, so Docker can choose a random port for each container. And it will scale the web for you. Now the beauty of this thing is, since Docker is now supported by Amazon and Google App Engine, what you can do is you can take your Compose file and launch it in Amazon and then have it scale automatically. All you have to do is take your image and push it to a public registry. That's how the Amazon works. What Amazon will do is you'll go there, you'll create a new project, and tell these are my images. It'll download those images, it will run them, just like I showed you here. And then you can tell it to scale, and automatically scale your images and scale your images down. It runs them on a special container that is optimized for Docker, a special OS that's optimized for Docker. Like,
are they able to start new instances?
No, you don't worry about starting new instances. It will.
Scale up basically.
They will do. It will take care of it.
But they will charge you the process.
They will charge you as much as they like, because they're the only guys in town and you're not going to run away from them. So they can charge you per second. They can charge you based on how hard you hit the keyboard. And you cannot say anything. But yeah, they have a interesting pricing model for this. It's also available on Google App Engine, but early preview.
What's the difference between Docker and CoreOS?
Docker and CoreOS or Docker and Rocket?
What is in CoreOS?
No, CoreOS is a stripped down version of Linux that has atomic updates, which means you don't update a certain package. You update the whole operating system in one go. Okay? And it's optimized to run containers. So Rocket is their implementation of a container format. It's not a container engine. It's a container format. Because containers are based on very old technology that's been there since the 60s. When you had mainframes and they used to partition mainframes, and even now they partition PowerPC. It's the same technology, but just like how Linux made it, Docker's made it public. So the Linux container model, which is used by Docker, it's something that's been there since donkey's years. They didn't invent it. They just made it easier to use.
You can use it for distributed computing.
No. There's a lot of confusion between what's the difference between Docker, Mesos, CoreOS, Kubernetes. There is 1,001 things revolving around Docker, right? So Docker, in and of itself, it's the name of the technology and the name of the company. It uses Linux containers to provide optimized, streamlined, runtime, isolated environments. This is what they do, right? In order to run Docker containers, you need an operating system. You need Linux. It needs Linux to run. It cannot run by itself. So you have many choices. You can have a complete, pick your flavor, Red Hat, Ubuntu, SUSE, whatever, Linux distribution running. And on top of this, you run the Docker service. And this Docker service allows you to then pull images, load containers, takes care of the networking for you, and all that stuff, which is what we're doing on our machines. Make sense? I can now go ahead and shut down Docker by just shutting down the service. It's like Apache. Okay? But because it allows density, which means it allows more virtual machines to run per hardware unit because you don't virtualize the operating system, which is one of the biggest. Like if you look at a typical VMware image, 80% of it is the OS. Maybe 20% is your code. And in VM land, the hardware is also virtualized, which means if you're using VMware or traditional virtual machines to do scaling, you will always be slower than your demand because it will take time for the OS to boot and then the application server to boot and then your application to boot. Not to mention the time it takes for the machine, the physical machine image to be moved around, right? In containers, there is very little You saw how quickly the container was launched. It's instant, almost instant. Because number one, the hardware has raw access. Your machine has raw access to it. Number two, you're not shipping a lot of things. You're shipping a very thin layer. You're shipping just deltas, essentially. In fact, suppose you have you downloaded an image, and let's say you downloaded the Ubuntu base image, or a very small base image, and now you start building on top of it your multiple containers, and multiple images from those containers, and then multiple containers from those images, and so on and so forth. You will reach a point where Docker does not need to build all the steps because it already can use the cached versions. It knows what's the smart change. So it only builds and compiles that part. You notice when I deleted my Python and I downloaded it again, it didn't download everything. It just downloaded the one line because it found the other versions to build the containers. It's a layered OS, right? So because of this, what has happened is there has been a new class of operating systems that are optimized for container use. One is CoreOS. Okay, CoreOS is a very stripped down distribution of Linux. One of the key components of it is it has atomic updates. Yani when you want to update the OS, you download the update, and you can store it in a directory. And when the machine boots, it will just boot the updated image. It's not like a normal Linux distribution where you have to download individual packages and update the individual package, and eventually the operating system will be updated, right? So CoreOS is that. The other thing CoreOS does is to facilitate distribution of nodes. It doesn't have an init system. You know an init system? It's what runs, the first process that runs is the init system. It then launches all the other processes. In CoreOS, the init system is distributed. It's a service that runs by itself. It's called etcd. Okay? What that does is it allows nodes to run and then discover where the other services are automatically as a distributed environment. So CoreOS is one, Project Atomic is another one. It's free. It's sponsored by Red Hat. It's what they use in Red Hat Enterprise version 7 for their atomic, for their container images. It's called Project Atomic. CoreOS is another one. I'm not sure. Maybe I don't know. So that's the difference. Now, Mesos is a way to take certain jobs and take multiple machines and use them as one resource. So think of it as like an operating system, but each service runs on separate computers. So it takes nodes and it turns them into an OS. And what you run on the OS are frameworks. So Hadoop is a framework that you run on Mesos. Mesos can then run Docker and then launch Docker. Kubernetes is a way to manage Docker machines that are running Docker containers for you. It basically tells you, here is my image repository, here is my configuration database. Run this image on whichever machine is available right now. Because you don't need to worry about the ports. It will map the ports automatically for you. So there is a great website you can go to Um, it's if you Google Docker ecosystem, it's the first map you will see, and it will not even fit on my screen. But here is all the things that are revolving around Docker. So there is the databases, configuration management. This is the container OSs that we were talking about. So you have Docker, you have CoreOS, you have Red Hat Enterprise Linux, which runs, there's Project Atomic is there. You have Microsoft, you have Project Atomic, you have Ubuntu, you have these other operating systems as well. Hosting providers that support Docker. Up here you have application development platforms that support Docker. Over here you have scheduling, orchestration, management applications supporting Docker. So there's Clocker, there's Crane, there's Docker Mix, Shipyard, which was one of the original ones. I think this one is now part of the Docker core. There was, here's Kubernetes. And Console, this is from the same guys who made Vagrant. It's a very good software. Mesos, as I mentioned, Stack Engine, etcd, which is part of CoreOS. Let's see what else you have here. These are the developer tools that you can use if you're working with Docker. Docker supports Heroku build packs, which is very nice. So you take Heroku build packs and run them as in Docker. Of course, Vagrant is supported. So as you can see, there's huge amount of, there's even software switches that are optimized for Docker containers. So lots of stuff available. Any other questions that I can answer?
Asking you guys about profiling.
Sorry?
Like profiling error logging, like just generally monitoring the instances.
Yeah, so there are many ways you can monitor instances. Docker provides a log. It tracks all the logs for all the Dockers, all the containers that's running. Just say Docker log and give it the container ID, it'll show you the logs for that container. There are special containers that are designed just to collect logs from other containers and provide them as a service. You can also use Logly or what's the other one? I forgot the other one. Basically, it just collects logs. But the easiest way to do it, mount a local directory on your host to the log directory and just collect the logs back. Mount it as a volume.
But I was more interested in like how does it actually work? You have the application, it's dumping logs into a file, and then that file is collected by Docker, and then Docker.
No, what Docker does is it. Let me show you. It's easier to show you than explain it. When you run a container, if you go to I forgot which. If you go to this directory, here is where all the volumes are stored. Here is where all the containers are stored. This is where Docker actually expands the archives and make them run. If you go in here, you'll see that you have your the host name, the resolve, the networking, the logs for the container performances. So the actual mechanics of running the containers is from the Linux container runtime.
So it's part of that.
Yeah. It's not. It's not a no. What Docker did was it took that and kind of made it easy for everyone to use. The container runtime has been around since, as I said, since the 60s. It's not new. It's not something, they didn't invent the container concept. That's what I'm trying to say.
Yes. So there's bound to be some kind of mature system.
Oh yeah. Let me show you a presentation that I have. It's so good I printed it out. I normally don't print out presentations. It's from the fine folks at Red Hat, and it actually explains what goes on behind the scenes when Docker runs. So here's your hardware. Here's the Linux kernel. C groups is what chops up your resources for each of the Docker container to use. And then the kernel just knows about C groups. The kernel doesn't know anything about your containers. Containers to it are just normal apps running in the user space. And then let me show you the other one. So here it is. This is the overview of how it all works. So you have the hardware layer, right? You have the drivers for the hardware. Here is your Linux kernel. Okay. Here is Docker. Docker talks to these built-in old from the 60s Linux kernel features, and then that's how containers run. So the kernel itself doesn't know anything about the containers. The kernel only knows about the Docker process. That's why when you want to do PS and a container is running, you don't see it. You have to do Docker PS. So read more about this to find out what goes on under the hood. It's very old tech. So, yeah. Any other questions? Yeah, sure. Go ahead. Ask. Sorry.
Your project does not contain any sensitive data. Do you mind pushing it?
Which project?
The API?
Oh, this one?
Yes.
It's already on GitHub. It's already on GitHub.
So your GitHub is GitHub.
I cloned it from GitHub. It's not mine.
Not yours.
No, I made some changes to it for this presentation, but it's a public project.
Second question.
Yes.
When you say Docker run,
Yeah.
Python,
Yeah.
then bash,
Nothing will happen. You need the IT in front of it.
there should be IT.
Yes.
So whatever is returning, you're only
Yeah. Go ahead. Sorry. So you're saying when I type Docker run
yes.
and then Python
Python.
and then bin bash.
So right now, after clicking enter, you are getting the bash, right? The terminal.
Yes.
Running which OS? The current OS. Right?
No, the OS that came with the container.
But Python doesn't have any container.
Python is the name of the container. For example, let me show you something. This is BusyBox. You know what BusyBox is? It's like, yes, go ahead.
It's the lightest binaries ever. It's optimized for microcontrollers.
It's a very, 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 very small Linux operating system that has, I think it has SH. That's it. It doesn't have bash.
Yeah.
This is it. Now, this shell that I'm running, it's running which operating system? The one that I pulled.
So basically, when you say Python as a container or as an image, it is not just the Python.
No. Let me explain.
It is the image itself.
Yeah. The way it works is, turn on the lights. And just move this across the So the way it works is, Docker, right? Run. Okay. I for interactive, T to capture the terminal. Here you put the name of the image, and here you put the command that you want to run once the image runs, once the container is up. If you forget this, whatever was in the Docker file will run. Does that make sense? So this is the syntax of the command. Run, the flags, the name of the image, and the command you want the image to run once it goes. When this image is running, it runs whatever operating system was used to build that image. Right now, I can download a Red Hat image and run it on my computer. And it will be running Red Hat. I will not use apt-get. I will have to use YAML. Okay. So the other thing I can do is I can say Docker run, and then name. So I can give it a name for me, like instead of that random name, so I can specify the name. Okay. If I know what the image is supposed to be, like I made my image, like I know that it will run a server and expose the port. Okay, then I don't need to do this. And what I do is I say Docker run, and then I immediately say -d, which means detach. Okay. And again, the name of the image, not the container. If it's a container, you have to start. And then I don't do anything else again because it's detached. Whatever I type here, I will not be able to capture the terminal. It will not block, it will not give me the TTY. Okay? So to get images from the repository, Docker pull. So just say Docker pull and then the name of the image. If you say Docker pull and the name of the image, and the image doesn't, it first checks your local store of images. If it doesn't exist, then it pulls it by default from the Docker public registry. You can give it a specific registry to pull. So you can say Docker pull and then the URL / and the name of the image. So it'll pull from there. Okay. What else? Oh yeah. You can type this command, docker inspect. I didn't show you this one. Name of an image. Name of a container. And when the container is running, it'll give you all the details about it. That's all. Okay. Suppose a container is running, and you want to load it and run a different command in it. You can do that as well. So a container is running your server, and something is wrong, and you're not able to check it from the logs. So type Docker exec is execute, okay? And of course you have to give it IT because you want to capture the output from it. Okay? Here you put the ID of the container, and then you give it the command. So you say, for example, bin crash. So what this does is, a container that's already running, execute this command and return me back the prompt. Okay? To remove containers, Docker RM. To remove images, Docker RMI. And you cannot remove an image if it has a container mounted, even if the container is not running. Okay? So to delete all containers at once, you can just type this little shortcut, Docker RM, Docker PS -QA. It will remove all the containers at once.
So basically, I run an image, I install a container, I commit a container
Back to an image. Back to
a
an image.
new image
Yes.
with the changes.
Yes. If you want. If you want.
Yes.
It's not required. It's not must. But usually what you do is you download a very basic, a very plain image, customize it for your application. Normally, you don't put your application code in it. You just load the libraries and you save it as an image. Then you deploy it on multiple machines. And if you want, you can choose to run different versions of your application because the data is, by best practice, it's mounted on volumes. Any data that's not mapped to a volume will be deleted when the container is deleted. Except, of course, if it's part of the image. So what we do at the office is we build the containers with all the data inside it. So our images are thick. We have a local repository server. Then we have a command that just takes the image and runs it on whichever node is free. And the networking is done automatically by it. So we don't worry. Like we can scale. It works well if you're running a static website. You can just scale 17 copies of it in one command. It's an application, you can still do it because you let Docker manage the network. I have another part of this talk, which is just for management. You're not a developer, you're a system admin, and you want to run a fleet of computers to run Docker containers. How do you manage them? How do you manage permissions? How do you check the performance? How do you move a container from one port to another? So,
That would be great. Maybe after having someone speak about
something else.
all that stuff.
OpenStack? OpenStack, something else completely.
No, how would they be able to utilize that? What type of hardware do they have to have in place
For what?
to manage this?
Nothing. Just computers and a network. You can have your Docker images running on AWS instances and manage them from your laptop.
Deployment will be
Sorry?
this will be a nice talk.
See, the good thing about Docker is what it does to you as a software developer is your output from your process is the image. We don't want the application from you. We want the image from you. And then you don't care. You have one image, run it on Amazon, run it on Google, run it on your laptop, run it. Hey, I'm having a problem. Okay, here you go. Here is the image. Just as long as Docker runs on your computer, the image will run. So as a software developer, it makes your life very, very, very easy. Additionally, it makes your life very easy because you want to help someone or you want to upgrade your application. And it's Dockerized, for lack of a better word. Okay? You take the image, you bring it on your laptop, and you run it against the new version of your source code, or you just simply run the tests on it, see what passes, what fails. And because it's incremental, okay, you can then, it's very easy for you to goof up and not have to worry about it.
Continuous integration is good.
Yep, exactly. That's what we do. We trigger our Docker builds based on a Git push. So I don't, you think I go there?
Maybe a use case for also similar virtualization, onboarding. Like when you want to onboard new developers, you only need to give them something very light. There's no console and machine.
These days, there really shouldn't be a doesn't really mind mission excuse. Honestly.
This is why, but this makes it easier. The previous
If this is what you need, you get better developers. Honestly.
I mean, the other options are
Even if the guy is unfortunate enough to run Windows, he's running Windows, it will work. You have to make sure your images are lean and not thick.
the other options,
Which is
entirely much
thick with extra cream on top.
I know a guy, he's changing his hard drive every 5 months.
Why?
Because he's running the budget cells on his machine. It's very huge. It's a huge. I will having his.
It would be cheaper for him to just buy a Drobo and swap the discs. Drobo. Not Drobo. Drobo. You know what's Drobo?
Yeah.
No, it's basically bring your own disc RAID machine. You buy the chassis, throw your discs inside. When the disc fails, take it out, put another disc in, it rebuilds your array for it. It's called Drobo. Wait, fine. I have it now on my where I store my downloaded episodes of Games of Thrones. Buy it. All right. Any other questions regarding who here is using Docker actively in production? Okay. Who here is using Docker for development?
I want to start today. Before.
Start.
I started, I downloaded it on the test container. I want to move all my
It's easy.
development.
Oh man, 2 hours max. For you, I'm talking specifically for your apps.
Yeah.
2 hours. And then you can do other cool things with Docker is you can tell a Docker what percentage of the CPU should go to which container. So you can do you can have nice. In Linux, there's the concept of nice, which is prioritize application resources. There's a similar thing with Docker as well. So it is nice. Yes. Okay. Any other questions? Yes.
Do you have an idea that if I can use Docker in digital ocean?
Yes, you can. Natively supported. And one of the quickest ways, just get a pod and if you want, I can give you a $10 credit coupon. Go there, and you'll get 2 pods plus. 2 of the lowest pods. They're one of the first ones to support Docker. Questions? Sure. Questions are free. Yes.
So the best way to run Postgres inside a Docker container is to mount the volume of the data on the local to the Docker and then have the whole application on the Docker.
Yeah. This is one of the best practices. You can also have containers that are nothing but volume hosts, and you can tell Docker to load the volume from Falana container into me, rather than from the And the best thing is, if you're running high security sensitive things, you can have a container that only mounts the volume as read only. So there is you cannot write to it. And whatever data is there at that point on the container, it will be overwritten when you mount it as a volume. So in other words, suppose you have a container where you added all your website static files, and it's running in production, and it got defaced. Just type this command and mount that point in your container like var HTML to a local directory host. In instant, it will just overwrite it. It's like the mount command in Linux, and your website will be back to the person. I mean, there are a lot of tricks you can do. Okay? Thank you. Oh, what is